Okay, notebooks are out, ready to go? All right, 4-2. All of 4-2. Maybe I'll give you a little break in the middle. We'll see how we go. We're going to do some right triangle trig. Trig functions of acute angles, you could say, but we'll just call it right triangle trig. And I have A, B, C, D, E. Whoopsie. And make sure you get your calculator out. It'll go by quick. You'll see. You'll see. You'll be all right. Do you have better things to do? No, you don't. Okay, letter A. Nothing's better than this right now. Oh, yeah. No. What's that saying? Sleep when you're dead? Okay, here we go. Right triangle trig. Let's do some triangles. First of all, let's talk about where our triangles are located, okay? So most of the things that we're going to do, even when we're doing a triangle or a circle, we're going to be in the Cartesian plane, okay? We're going to be in a quadrant. So we talked about this a little bit. This is quadrant 1, quadrant 2, 3, and 4, and they go around in a counterclockwise direction, which might seem kind of strange to you, but when we talk about angles, what we do is we usually put this right here. Here, I'll do it in a different color. That right there is going to be to start an angle in standard position. Your initial side of your angle is going to be on the x-axis, the positive x-axis, and if we wanted to get a positive angle, we would go in a counterclockwise direction and open up our angle, and that gives us theta. Okay? So what this is called an angle in standard position. Standard position. Standard position means that the vertex is at the origin. Vertex is at the origin, and that the initial side is on the positive x-axis. Initial side of your angle is on the positive x-axis. You can put an angle in not standard position. It's just we usually do an angle in standard position. All right. Do you know anything about angles? Do you know what an acute angle is? What is an acute angle? Yeah?
Less than 90.
Perfect. Not just less than 90, but actually between 0 and 90. Because we're going to have some negative angles coming up, and those are not acute. So 0 degrees to 90, or 0 to pi over 2 radians. Oh, we have two angles, two measurements of angles. Okay, so now let's get into a triangle. Here we go. Let's draw our triangle. You know, my triangles always look the same. So triangles never drawn to size. But we're going to draw a right triangle. We're going to do some right triangle trig. There's also not right triangle trig, but that's going to come later. Right now we're doing right triangle trig. So we have a 90-degree angle in our triangle. That makes it a right triangle. And we'll call this point, or this vertex, A, B, and C. Okay? Usually with triangles, across from them will be their lowercase. Like if I want to talk about this side over here, some people will call that side BC. We will call it lowercase a. Across from C, we call that lowercase c. And then the side across from angle B is side lowercase b. So your angles are always uppercase and your sides are always lowercase. Okay? All right, now these have different words associated with them. So let's go ahead and put theta over here at angle A. We're going to call this theta. Okay? Now looking at theta, or angle A, the side across from that angle, this is going to be the opposite side. It's the opposite of your angle. Okay? The side right next to your angle, not the long side over here, but the side right next to your angle, do you know what that's called? Adjacent, yes. This is the adjacent side. Adjacent means right next to. And this one's also next to A, but it has a special name. What's the side across from the right angle? Hypotenuse. Hypotenuse. Oh man, I ran out of space. Okay. Now, you learned this in geometry. We're going to find the sine, cosine, tangent of angle A. And you learned this as SOHCAHTOA, right? Maybe you don't remember what that stands for. But if we're going to find the sine of an angle, then we go to this first part, SOH. So let's go ahead and find the sine, and sine is abbreviated SIN, okay? It's really written as sine, S-I-N-E, but we say S-I-N, and you cannot just say sine of nothing. It has to be sine of something. We'll say the sine of theta. The sine of theta is equal to the opposite side over the hypotenuse. So sine is a ratio. They're all ratios. The ratios of the sides of a right triangle. So the sine of theta is opposite over hypotenuse. Okay, the next one we're going to talk about is CAH, C-A-H, and that's called cosine. And when we want to find the cosine of an angle, we abbreviate that as COS. And the cosine of angle theta in this triangle, in all right triangles, is AH. So it's the adjacent side over the hypotenuse. And that's cosine. And then the last one is called T, which is tangent. And tangent's funny because tangent shows up like 3 times in math. And they're all different from one another, but they're all called tangent. Like you can talk about like a tangent of a line, or a tangent of, like if you're on a circle and you're walking and you go off on a tangent, that means like you're going to go right next to it and go off in a different direction. But this is a different kind of tangent. This is tangent of an angle, tangent of theta, and tangent is TOA, which means opposite over adjacent. There you go. Now, those are the 3 basic trig functions. There's actually 6, though. You haven't learned the other 3 yet, I don't think. Okay? All right, the other 3 are going to be their reciprocals. They all have a reciprocal. We're going to flip them all. Have you learned it? No? Okay. The first one is called cosecant. Cosecant. Weird word, huh? Cosecant is abbreviated as CSC. And the cosecant of an angle is going to be the reciprocal of sine. So sine and cosecant go together. They're just going to be flipped, the reciprocals. So cosecant of theta is the hypotenuse over the opposite. Okay, and you don't have to memorize that. Just know that cosecant and sine are reciprocals of each other, and then all you have to do is find out what sine is and just flip it. All right, 2 more. There's also secant. Secant. The secant of an angle is abbreviated SEC. The secant of theta is going to be the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And then finally, the last one is called cotangent. And cotangent is abbreviated COT of theta, and that's going to be the reciprocal of tangent. So it's adjacent over hypotenuse. Okay? So looking at this, sine and cosecant are reciprocals. Those go together. Okay? And then cosine, cotangent? Yeah. Oh, adjacent. Oh, thank you. Sorry about that. I need an eraser. Come on. Oh, I have to pick an eraser. That's not erasing. There we go. Thank you. The last one is wrong. It's adjacent over opposite. Oopsie. Oh, oops. No. What am I doing? All right, so cosine goes with secant. And the way that some people will remember that is that sine starts with an S, but its reciprocal starts with a C. Cosine starts with a C, but its reciprocal starts with an S. So they each get one, CS and CNSC, okay? And then no one ever forgets tangent and cotangent because they're almost the same word. There we go. All right, so what are we going to do with these? Well, we're going to do the same thing you did in geometry, where you're going to be given a triangle, and then you're going to have to find out what the sine, but we're going to find all 6 of them, though. So here we go. First example of the day, number 1. All right, suppose that I have this triangle here, where this side is 5, the hypotenuse is 15, and our right angle is there. And I'm going to go ahead and put theta over in this corner. This is theta. And we are going to find the value of all 6 trig functions of theta. Find the value of all 6 trig functions of theta. Make sure that when you do these, you reduce all fractions. Make sure that you leave them in radical form if there's radicals, and that they're in reduced radicals, simplified, rationalized form. Yeah, you got to rationalize. Okay, I'll show you. Here we go. You ready? We're going to find all 6 of them. So let's first find the sine of theta. I usually start with sine. So sine is going to be SOH, so opposite over hypotenuse, 5 over 15, which would be 1/3. Okay, I'm going to go ahead and find cosecant of theta now, because sine and cosecant are just reciprocals of one another. So what would the cosecant of theta be? Yeah, 3 over 1. It's just going to be the reciprocal of sine. You don't even have to remember that it's hypotenuse over opposite. You just know that it's the reciprocal of sine. Okay, now let's find the cosine of our angle. So the cosine of theta is adjacent. Oh, shoot, I don't have adjacent. Do you know how to find that? Pythagorean Theorem, yes, Pythagoras. There he is. All right, let's call this side A, and we're going to do the Pythagorean Theorem over here. We're going to do a squared plus b squared, 25, equals c squared. Okay? So let's see what all of that is. Does it come out nicely? I hope not. I want to show you what happens with radicals and stuff. Well, it does not come out nicely. Okay, perfect. All right, so we get that a is the square root of 200. Now, a couple of things. Number 1, you cannot leave that as the square root of 200. You're smarter than that. You know that the square root of 200 is 100 times 2. And you know the square root of 100 is what? 10. So you need to write this as 10 rad 2. Okay? That comes back from Algebra 2. You learned how to do that last year. We even did a little bit of it this year, too. Do you feel pretty comfortable with that, or do you need a little schooling on that? You're pretty good. Okay. All right, so here we go. A is equal to 10 rad 2. So now let's go ahead and find the cosine of theta. Cosine of theta is going to be adjacent over hypotenuse. So 10 rad 2 over 15. And then let's reduce our fraction. 5 will go into 10 and 5 will go into 15. So we get 2 rad 2 over 3. Okay? All right. Now that we know cosine, we can find secant very quickly. Well, not really quickly on this one, but we know it's going to be the reciprocal. So let's take the reciprocal of 2 rad 2 over 3. So that would be 3 over 2 rad 2. And now what we need to do is we need to rationalize. You're not supposed to leave radicals in the denominator. So do you remember how to fix that? Perfect. Yeah, I heard it. Multiply top and bottom by rad 2. So you get 3 rad 2 over 4. All right, 2 more to go. There's like 6 problems in one, huh? Isn't that fun? All right, tangent. Tangent of theta. Tangent is TOA, opposite over adjacent. So 5 over 10 rad 2. let's reduce that first. So that's 1 over 2 rad 2. And then we can rationalize that and get rad 2 over 4. Okay, and one more to go. Cotangent of theta. Cotangent, what you should do when you're doing reciprocals is go back to here, to where you haven't rationalized it. Okay, because if you go to here where you rationalize it, you're going to have to re-rationalize it back. So just go to here where you, before you rationalize it, and then just flip it. So cotangent would be 2 rad 2. Okay? All right, let me show you now on your calculator how you can get those same answers, but not really. Some of them you can. All right, so let's look back here at sine of theta equals 1/3. Actually, no. We're not going to do this on our calculator yet. Nope, never mind. We're going to do angle measures on our calculator, so don't worry about your calculator yet. Okay, let's go to part B now. That was just part A. That was probably the longest part, though. So, what do you have that's better than this? Nothing. I'm serious. All right, we're going to talk about two famous right triangles. Two famous triangles. Okay? All right, triangle famous number 1. The first triangle that's famous is going to be a right triangle that has sides both equal to 1, which would make the hypotenuse 2. Good. And this would then mean that what are the degrees of these angles here? 45, yes. This is a famous triangle. It's the good old 45, 45, 90 degrees. Do you remember this from Geometry 2? A little bit? Okay. Now, oh, sorry, rad 2. I wrote 2. Man, I'm messing up today. I'm a little rusty coming back from Christmas, I think. So were you guys thinking that back there? I thought I heard something like, that's rad 2. Yeah. Good job. Okay, call me out though. Like, yo, hello, that's wrong. I make mistakes. It's even right on my paper, but I still made a mistake. So. Okay, so now if we had to find, for example, the sine of 45 degrees. The sine of 45 degrees is going to be opposite over hypotenuse. So 1 over rad 2. And then if you rationalize that, your answer would be rad 2 over 2. Okay, now I want you to go to your calculator. So go to your calculator and let's see what your calculator says the sine of 45 is. Couple of things. If you're in physics, you might already know about modes, right? You know about sine and cosine tangents. Very careful to be in what mode. If you're not in physics, let's go ahead and talk about that anyways. All right, so go to mode. And right now, my calculator is in radian mode. Now, you know what radian is now. We have an angle measure that's radian, and then we have an angle measure that's degree. Am I using radians or degrees in this problem? Degrees. So I want to go ahead and change my mode to degree mode. I'll show you another way to do it that you don't have to do that. Okay. And now let's find the sine. So sine, cosine, and tangent are all right here. So let's find the sine of 45 degrees. If I was in radians, I would be finding the sine of 45 radians. Do you know how many 45 radians are? That's a lot, right? 1 radian is 57 degrees. 45 of them, you're going around and around and around. So I want to find the sine of 45 degrees, and it gives me this ugly number. Guess what that ugly number is? That ugly number is rad 2 over 2. So a lot of times we're not going to use our calculators because I don't want you to give me the answer is 0.707. I want the answer is rad 2 over 2. Now you can check it if you remember them. Okay, you can check it. If you square that, it'll give you 1/2. If you square that, it gives you 1/2. It's another way to check it. Okay. Now the cool thing on this is that with sine and cosine, they're exactly the same. This is the time when they're the same, when there's a 45-degree angle here. So the cosine of 45 is also 1 over rad 2, which is rad 2 over 2. And we're going to end up memorizing these. We're going to have a unit circle. I don't know if you ever heard of a unit circle, but we're going to start memorizing some of these. Tangent is a nice one on this one, isn't it? What's the tangent of 45 degrees? It's 1. Your calculator will tell you that one for sure. So if you go to tangent of 45, there you go. Now, if you don't want to change out of radian mode, like let's say you like radian mode, you can always do this. Tangent of 45, and then go to second angle and put in a degree symbol. Okay, so you can always do that, 45 degrees, and it'll tell you the right thing. And if you leave out that degree symbol, though, you're taking the tangent of 45 radians, which is totally different. All right, now, if you wanted to do the reciprocals, okay, like if I wanted to find the cosecant of 45 degrees, like I said, you would want to go back to where before you rationalized it and flip your fraction. So sine of 45 is 1 over rad 2. Cosecant of 45 is simply rad 2. Now, cosecant is not on your calculator, but you can use your calculator to find cosecant by using the reciprocal. Cosecant is not the same thing as sine to the negative 1. They're not equal, okay? Your calculator has sine inverse. And sine inverse is not the same thing as the reciprocal of sine. So if I wanted to find on my calculator how to do cosecant of 45, I would do 1 over the sine of 45. Okay? So let me go and change my mode back to degree. So I would do the sine, 1 divided by the sine of 45 degrees, which gives me 1.41, which if I check it, that's rad 2. Okay? It's a lot in one day, isn't it? Rad 2. All right, now I told you there were 2 famous ones. So what's our other famous right triangle? Anybody know it? Yes, you got it. It's the good old 30, 60, 90. And remember we did these angles yesterday? We did 30 degrees, which is pi over 6, and we did 60 degrees, which is pi over 3. These are special angles to us. Okay, let's draw a triangle of the 30, 60, 90. All right, so this would be 30 degrees over here. 30 degrees is going to be across the shorter side. 60 degrees is across the longer side, and then the right angle is across the longest side. And across from 30 is 1. What they do, they show this in the book, is they take an equilateral triangle and they break it down. And this would be 2 over here, and this is rad 3. Do you remember those a little bit, maybe? Okay. But you can find, looking at this, let's go ahead and find the sine of 30 degrees. Just by looking at this triangle. The sine of 30 degrees is going to be opposite over hypotenuse, 1/2. And your calculator will tell you that too. Since it's a nice number, it's not irrational, it's a nice rational number, your calculator would tell you that sine of 30 is 1/2. What's the cosine of 30 degrees? Cosine of 30 is going to be adjacent over hypotenuse. So that would be rad 3 over 2. And then the tangent of 30 degrees is TOA. So opposite over adjacent, 1 over rad 3. But make sure you don't leave your answer like that. You need to rationalize it. So the tangent of 30 is rad 3 over 3. And then you can find all the other 3 of them by just flipping all those reciprocals, or getting the reciprocal. All right, do you need a little break? We've gone 25 minutes just about. You want a little stretch break? Or you want to just keep plugging on? Let's just keep going then. Okay, here we go. Part C. All right, it says here that we're going to use some ratios to find all the 6 trig functions of a triangle. So it says, number What are we on? Like, oh, 2? I didn't label those last ones. They should have been labeled. Oh, well. All right, number 2. It says to let theta be an acute angle, and the sine of theta is given to us as 5/13. We want to evaluate the other 5 trig functions of theta. Okay? So we're told sine, and from that, we will be able to get all the other 5 trig functions from that one sine. All right, in trig, what you're going to do most of the time is you're going to draw a picture. Okay? So let's go ahead and get a triangle going. And my triangles, like I said, they're always going to look the same. They're not, but oh well. And then let's just put theta anywhere you want to. Doesn't matter. And theta, the sine of theta is 5/13, which means across from theta is the opposite side. And what's the length of that opposite side? 5. Perfect. What's the length of the hypotenuse? And this is the old what triangle? The old 5, 12, 13? No? No. Do you know some of them? Some of the Python, 3, 4, 5? 3, 4, 5 is the most famous one. The 3, 4, 5 triangle, 3 squared plus 4 squared equals 5 squared. This is the old 5, 12, 13 triangle. There's some of them that are really nice. This is one of them. Okay, if you didn't know that, that's okay. You would do 13 squared minus 5 squared, which would give you, what, 144? Square root of 144, 12. Okay, and now you can find the rest of them. Isn't this exciting? What do you want to find first? Cosecant? I would probably find cosecant first because it's just going to be the reciprocal of sine. So the cosecant of theta would then be 13/5. The cosine of theta would be adjacent over hypotenuse, so 12/13. The secant of theta is the reciprocal of cosine, so secant would be 13/12. 2 more to go. At least we don't have to rationalize on this one. Tangent of theta is opposite over adjacent, so 5/12. And finally, cotangent of theta is 12/5. Yay. Feeling pretty good? Do you need another one of those? Do you feel like you're comfortable? Okay. All right. Sometimes they're not going to turn out to be nice, like 5, 12, 13, 3, 4, 5, like nice triangles. So you'll have to have radicals. But leave them in radical form. Okay. All right. Let's do letter D. See, it's going faster now. I told you. All right. We've already done this a little bit, but let's go ahead and get our calculator out, and let's just find some trig functions of not nice numbers, not our 30, 60, 90, or 45, stuff like that. So let's go ahead and evaluate. So number 3, evaluate the sine of 10 degrees. And these are all going to be approximations, and you can just approximate to like 2 decimal places is fine. Let's find the cotangent of 30 degrees. Okay. Let's find the tangent of 60 degrees. No, I don't want to do a nice one. 65 degrees. Okay. So let's just go ahead and evaluate these 3. So go to your calculator. And we have degrees here, so we're going to be in degree mode. I just check it to make sure. And I want to find the sine of 10. I don't have to put in a little degree symbol if I'm in degree mode. It takes care of it for me. So the sine of 10 would then be 0.17. Let me see. How many decimals do they want you to round to? Do you know? We don't usually do decimals a lot. It looks like they have 3 decimal places. So let's just go to 3. 174. All right, cotangent. Cotangent, if you remember, is not tan inverse. It's not tan -1. Cotangent is going to be you're going to go 1 over the tangent of 30 in your calculator. Okay, we're going to get a decimal approximation of that. 1 divided by tangent of 30 degrees gives me about 1.732. And then the tangent of 65 degrees, tangent 65, 2.144. There we go. All right, so that's with your calculator, okay? Now, number 4, we're going to now evaluate without our calculator. And when I ask you to evaluate without a calculator, it's going to be one of the nice angles that we already talked about today. So let's go ahead and find the sine of pi over 3. Okay, if I went to my calculator and I wanted to evaluate the sine of pi over 3, I'd go back to radian mode because there's no degree symbol. So if there's no degree symbol, you automatically know it's radians. So I'm in radian mode, and I do the sine of pi over 3, and it gives me this 0.866, okay? If they're asking for an approximation, that's fine. If not, you need to know what 0.866 is. Do you know what 0.866 is? No? Okay, that brings us back to our 30, 60, 90 triangle. Pi over 3, what is that in degrees? No? 60. It's 1/3 of a pi. Okay? A whole pi is 180. It's 1/3 of that. So it's 60 degrees. So we need to go back to what we did in, what part was that? Part B. Part B, and we need to look at this triangle here. And instead of writing this, this would be pi over 6 over here. And this is pi over 3. And this is 90 degrees. Pi over 3 is 60 degrees. So this would be rad 3. And this is 1. And this is 2. So then the sine of pi over 3 is to go over here and do opposite hypotenuse. So rad 3 over 2, which is approximately 0.866 if you did it on your calculator. Okay, so when they're going to be pi over 3, pi over 6, pi over 4, those are all going to be nice numbers. Well, not nice numbers, but we're going to have them in radical form. All right. We did that, we did that. Okay, last part. Letter E. Okay, we're going to do some applications. And these are just going to be like little easy applications at first. When we get to the last lesson of this chapter, there's going to be harder applications. But basically, if you had to solve a triangle, that's what it's called, usually three parts of the triangle is enough to solve the whole thing. A triangle has 6 parts. It has 3 angles and it has 3 sides. Okay, and in order to solve a triangle, you need 3 of those things. So here we go. Number 5. Number 5. It says, suppose that you have a right triangle and the hypotenuse is equal to 8. And one angle in your triangle is 37 degrees. What we want to do is we are going to solve the triangle. Solve the triangle means find all of the other missing parts. Okay? They gave me 3 things here. Solve the triangle. All right, so let's just start with a triangle. There we go. It's a right triangle. So I'll go ahead and put a little right angle there. The hypotenuse is 8. And one angle is 37 degrees. Let's put 37 degrees right there. All right, so our job then is to find out what this angle is over here in red. We need to find out the length of that side, and we need to find out the length of that side. So there are 3 things left for us to find. All right, one of them is easy, right? One of them, you should know how to find this. You learned this in geometry. How many degrees makes up a triangle? 180, perfect. So this is 90, 37, that's going to be 90 minus 37. So I'm just going to say my angle measure is what? 53 degrees, perfect. angle measure, 53 degrees. You know what, let's label this. Let's label this as A, B, and C. So we'll say that angle B, I don't even know if that's the right notation for that. Taught geometry like 18 years ago. All right, so the measure of angle B is 53. All right, let's go ahead now and let's find out what this blue side is. I'm going to call the blue side little a because it's across from angle A. All right, any ideas on how to find out what A is? Well, I have this 37 right here, and 37 is opposite of A, and I know the hypotenuse. So what trig function can I use? How about sine? I can say that the sine of 37 degrees is equal to what? Perfect, yes. A over 8. So I can solve for A now by multiplying both sides by 8. So A is going to equal 8 times the sine of 37 degrees. 37 degrees is not a nice angle. It's not one of our special angles. So we're just going to go ahead and put it in, get a decimal approximation, round to one place. It's fine. So we're going to go 8 times the sine of 37. Oh, wait. I'm in radian mode. Okay, if you're ever not sure, check, or you can put a degree symbol in. So 8 sine 37, then A is going to be approximately 4.8. And then we can find out what B is over here a couple of different ways. You can either do Pythagorean Theorem, because once you have A, you do 8 squared minus A squared equals B squared. Or we can do cosine. It doesn't matter. I'll just do cosine. I would say the cosine of 37 degrees is equal to adjacent over hypotenuse. So B is going to be approximately, is it going to be bigger than A? Should be. You can hit second enter and change that sign to a cosine if you want to. B is about 6.4. There you go. We solved the triangle. We had 3 parts, and we found 3 parts. Okay, now let's do one last problem. There's a light at the end of this dark trig tunnel. All right, number 5. An application problem. 6? Number 6. Not labeled on my paper, right? All right, we're going to find the height of a building. Can we measure it? No, it's too tall. All right, it says from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia. Anyone ever been to Atlanta, Georgia? No? I have. People there are so friendly. Okay, anyways, so here's the Peachtree Plaza Hotel. Is that what it was called? Or just Peachtree Center Plaza? There it is. And it says from a point 340 out from it, so we'll call this 340 from here to here. Okay, that's 340. It says here that the angle of elevation to the top of the building is 65 degrees. Now let's talk about angle of elevation. The angle of elevation is here you are standing on the ground, or maybe laying down from the ground, and you're looking up at the building. Your angle of elevation is going to look like that. That looks like 45 degrees, doesn't it? It's 65. Your angle of elevation to the top of the building is 65 degrees. Okay? And what we're going to do is we need to find out what the height of the building is. Find the height. All right. And this is a right triangle. This is not the leaning tower. Yes?
So we're not going to account for how tall the person is?
No.
Okay.
I know, right? You're laying down on the ground.
But then you still have about 2 inches.
That's true, too. Yes. Oh, it even says here. Yeah. It even says that, notice that applied problems, it's illogical to give answers with more decimal places of accuracy because this isn't very accurate. It actually says it in the book. Like, how do you know that you're exactly 340 feet? How do you know that's 65 degrees? It's all like an approximation. So maybe like if you're 6 foot tall, it's not going to matter that much. It might matter some, though. Yeah. Okay. I like that, though. I like that you're thinking that. All right, so let's go ahead and find the height. So let's look at what we have. We have an angle, and we need to find the opposite side of that angle, and we have the adjacent side. So which of our 6 trig functions, and we usually only pick out of the 3, which one should we use? Tangent. Yes. So here we go. The tangent of 65 degrees is equal to opposite over adjacent. So then the height would be, and they want you to round to the nearest whole number. They don't want decimals here. Okay? So we're going to go 340 times the tangent of 65, and we get that the height of the building is about 729 feet tall.